Okay, if you look at the student experiments on this, they actually use words where they're talking about the different types of error. Now, that is the types of error you look at when you're using instruments and stuff, so don't worry about that right now. All we're looking at is talking about whether your results are reliable and accurate. So a few things to start off with. The difference between reliable and accurate. Try and use your words properly. Reliable means you're getting the same result over and over when you repeat your trials. So you might have answers that are very close together. That's good, that's great, that's what we call a reliable. It's not always what we call accurate though, because that depends on how well you've measured it. Something can be reliable but not accurate, and that depends on how well you've set up your measuring method. So that's a picture of what is inaccurate but reliable. However, accurate means that its average is pretty much fitting with what we know is or what we think is the answer there, but it can either be spread out like this, which means it's unreliable. You had a lot of variation in your data, but it was accurate, or it's actually quite reliable as well, where it is closely together, which means there's low amount of error in how you've measured it, and it's quite accurate too. So it follows the trend of what we think is happening. So how do we then talk about this? You need to just talk to me about whether or not you had a lot of variation in your data. So was your range quite large compared to your average? And also, why do you think that came into effect? How do you think you can actually improve it? So you need to identify for me sources of error, things that you actually think caused error in there. For increased marks, not just sources of error, you need to tell me how that would have affected your data. Would it have increased your count, decreased your count? How would it have affected your data? Okay. Now this is really important because it really shows that you're thinking about this. So the classic one that I'll often say is if you increase the temperature, and yes, I won't count this when you actually write this in your report. If you increase the temperature of any of those solutions, but not too much, because the liquid is increased in heat, remember that reactions only happen when particles collide. So that collision needs to happen. Now they're going to collide a lot quicker if they're moving around faster. So as you increase the temperature of your solution, your particles are going to collide quicker, and therefore they're going to react faster no matter what, as long as you don't increase it to a point where you endanger your yeast. So if you guys had different temperature solutions for all of your different practicals, you've got some which no matter what you add to them, if one's say at 25 degrees and one's say at 30 degrees, neither of these temperatures are going to kill your yeast. But these guys here definitely have the particles moving around faster, therefore their chemical reactions are definitely going to be faster no matter what, because the particles are colliding and hitting and reacting. So that's where chemistry comes into it, by the way. Told you you'd be using it one day. So you guys need to understand that that is an error, but not only have I said, oh yes, the temperature varied from the different experiments, we need to improve that. I've told you how it's affecting your data. It was supposed to all be the same temperature, but this guy here had a higher temperature compared to him. Therefore, this data here is going to be bigger than it should have been compared to this one here, no matter what, because they were different temperatures to begin with. So that's the thing that really starts to show me you're thinking about this. Okay? Now, last but not least, you must tell me how you would improve this, how you would fix this. That also shows me you're thinking about this. What would you do to make sure that this didn't happen again? How could you fix it? Now, one of the things that I put in there for all of you guys to do was I limited you to the 2 minutes. Now, there's a good reason for that. That little test tube loses heat quite rapidly. Over a 2-minute period, it doesn't really change temperature much if you actually measured it. But if you left them and took measurements over like 10 minutes, well, the temperature is dropping that entire time. So your reactions the particles are slowing down over that entire time period, you'll see a decrease in your bubbles no matter what. So that is one of the inherent parts in that method that I actually put in there to help keep your data reliable, okay? Because in there it was actually making sure that you were able to have all of the same amounts of data given the same conditions so that you could do your counts more accurately. So that's an example of how you do this. For every type of error you can see, I want you to identify what you think it was, what caused it, try and talk to me about how this affected your data, and then tell me how you're going to fix it. I hope that makes sense, guys. Remember, it's quality, not quantity in this case here. Give that a go, and as we get more into student experiments, we're going to go into the level of what I expect in your write-ups even more, and there'll be further videos after that.